Good afternoon. We're going to do the specific heat lab today. So our purpose is to determine the specific heat capacity of an assigned metal. We're actually going to do 4 different metals, and we have little cylinders of each metal. For the pre-lab, I need you to answer what is the equation for specific heat and define each variable in the equation, and draw a diagram showing the system and the surroundings of our setup. In our lab today, we have a 600 milliliter beaker over our Bunsen burner. We're going to use it to heat the water to a boil so that we have hot water to then heat up our mass of our metals. So we have 4 metals we're going to heat inside the boiling water. Then I'm going to measure out carefully 30 milliliters of distilled water and put that into my styrofoam cup. Okay, so we're going to put the water into the cup at room temperature. We're going to take the hot metal out and put it into the cool water, and we're going to see how much heat energy came out of the metal and went into the water. And we're going to calculate that using our MCAT equation, where Q equals the mass times the specific heat times the change in temperature. All right, so what are we actually studying? We don't necessarily care about this water. That's only a means to heat up our metal. What we care about is the metal in the water, and specifically what is the system and what is the surroundings. So you guys are going to draw a diagram of the metal in the water and label the system and label the surroundings. While we wait for the water to come to a complete boil, it's been heating on the Bunsen burner for about 5 minutes. It's almost boiling. While we wait, we're going to take the masses of our 4 metals that we'll be using. They are iron, tin, this one is zinc, it has the symbol on the bottom, and lastly copper. Okay, I put the weigh dish on the balance and I'm going to zero it. Okay, so the mass of our iron is going to be 58.16. Again, the mass of iron is 58.16 grams. The mass of tin, you can see how shiny this tin is. It doesn't oxidize very easily. The mass of tin is 58.12. Okay. And you know what? I'm going to go ahead and re-zero this. It says 0, but just to be sure. Okay. The mass of my zinc, disregarding the string, 58.12 is the mass of zinc. 58.12. Okay, and last but not least, our copper, 0. The mass is 58.17. Make sure you put the units of grams. You should organize this into a data table, and just for fun, we're not going to use aluminum today. Number 1, it doesn't have a string tied to it. Number 2, it's so tall that it requires more water than the others, and I would rather not have that variable in there. So the mass of this aluminum is 57.92. So they're all a very similar mass. You can kind of tell their relative densities based on the volume, if you can see them. So the smaller it is, copper is the smallest one, the more dense it must be because it has the same mass as the other packed into a smaller volume. And you can see aluminum is very low density because it is such a big state. All right, so I have measured out my 30 milliliters of water. This is going to go into my coffee cup calorimeter, which is just a doubled up styrofoam cup. And we are going to take the initial temperature of our 30 milliliters of water with my thermometer here. Okay, oh, that would help if I put it in the correct way. All right. Can you see it? Can we read that? There's the lines. And remember, when we're taking temperature, it's kind of hard not to, but we want to not touch the bottom because it could potentially have a different temperature than what it is we are measuring. Can you guys read the temperature there? Remember to include a tens place. So I would say that looks like, I'm trying to make sure I give it enough time so that it stops moving. And it actually went down a tad, I would say. Ooh, there we go. Now you guys can maybe read it. Okay, I would read that as 27.1. It's just slightly past 27.1. So we are reading all of the tick marks and we're estimating the last one. Okay, so let's record our initial temperature, TI, 27.1 degrees Celsius. And our water is boiling. I don't know if you can see it with the white background, but it's definitely boiling. And let's take the temperature of that, just for good measure. This goes up to 150, so it should be all right. Give it a little stir. Okay, it's rising very quickly. And because we are not at sea level, and because this is not pure H2O, this is tap water with a lot of contaminants in there, it might not be exactly 100, but it should be relatively close to 100. Let's see if I can move my fingers and get a reading on this. It's still rising. It rises much slower when you get towards the end here. Okay, it's about 99 right now. That might be all it's going to rise. Okay. It looks like 98. Oh, no, it went up. 99. It is staying at 99.0. So our temperature of our initial temperature of the water, which is going to heat up our metal until they become the same temperature. So it's going to be also our initial temperature of the metal is going to be 99.0. Okay. All right. So let's start with our iron. We're going to heat this up for 3 to 5 minutes. I'll come back when we're ready to plop it into the cool water and find the equilibrium temperature. All right, it's been 4 minutes, so our metal has had time to come to equilibrium with the water temperature. So the metal is 99.0 degrees, and I'm going to quickly take it out and put it into the cold water or room temp water before it has time to lose much heat to the air. And then we're going to quickly put the thermometer in and record the highest temperature. Okay, notice how I'm bringing the cup over to the water. So I just want to quickly plop that in there. And I'm tilting it to cover the metal completely. It was sticking out just a little bit, and that means heat is going to escape into the air. So let's find our final temperature, not touching the thermometer to the metal. Okay, and it's rising. Right now it's at 34. Needs to get all of the heat into, you guys can we see? I'm trying to keep it covered here and record the temperature. Okay, it's at 37.0. Swishing the water around a little bit to mix it. We don't want to stir with our thermometer. It's at 38. Staying at 38.0. And it hasn't moved. So they might have reached equilibrium already for their average kinetic energy. It's at 38.0. Let's see if it starts falling, then we know that was the highest temperature. And now it's going to start coming to equilibrium with the air if it cools down. Making sure I get all of the heat out of that metal. Yep, it started dropping, so it's at 37.5. So the high that we're going to record for our iron was 38.0. Don't forget those decimal places. All right, I'm going to heat up. The next metal is tin. I'm going to heat up tin by carefully lowering it into my boiling water. And we're going to leave it here for 3 to 5 minutes to come to equilibrium. I'm going to pause while I heat it up, and we'll come back and take the temperature of the water, of a new set of water with my tin. All right, so the metal has been heating for 4 minutes. I am going to dump out the old water. Okay, so there's no more water in the cup. This is fresh distilled water, and its initial temperature is 27.0. Okay, so the starting temperature of my room temp water, 27.0 degrees Celsius. Make sure you record that, please. That's going into my styrofoam cup. I'm holding the string up so it doesn't fall into the flame and catch fire. That would be bad. All right, so I have my cool water. I have my very hot 99-degree metal. I'm going to plop that in quickly, and we're going to record the highest temperature that it reaches. All right, and with 30 milliliters, you have to tilt it a little bit for the metal to get covered completely. Let's see if I can show you guys that. Okay, when I tilt it about there, the metal is completely covered. Yeah, let's record. Okay, temperature is definitely rising. It's at 30 right now. Right, 33, and it's going up still, so that's not our highest temperature. It's at 34. Okay, trying not to touch the metal and try to keep the metal covered and try to swish the water around. Gonna multitask here. We're at 34.0. And it actually went down a little bit. Let's see if 34.0 was our high. Okay. Yep, it's going down. So the high was 34.0, and now it's gone down just a tiny bit. Okay, so we're going to record that and start with fresh water with our next metal. All right, our zinc has been heating for 4 minutes, and we are ready to add the fresh water, which this has an initial temperature. So for zinc, the initial temperature is 27.5. I think it went up just a tiny bit because of the amount of heat that's being given off by the Bunsen burner for burning for this long. So 27.5 is our initial temperature for water for zinc metal. And I'm going to put that in my empty styrofoam cups. And we're going to plop this zinc in carefully and quickly and record the highest temperature. Okay, it's gone up to 30. Let's see how high this one rises. Okay, it's past 30, almost 35. Keep that covered so I don't lose heat to the air around it. See, it's hard to show you everything that's going on at the same time. Ooh, that's really going up there. Let's see what our temperature is. We are at 36.9, 37 degrees Celsius and rising. I feel like zinc has a high capacity to store heat energy. It's releasing all of that energy into the water, causing the temperature of our water to go up. And you guys know that heating water is not easy because it has a very high specific heat. So that's why the temperature of the metal changes much more drastically. We are at 37.9. And it appears to be going down. Okay, it's gone down to 37. So 37.9 was the high for zinc. Okay, I'm going to put the copper in last and let it heat up. We'll come back to that. All right, last but not least, we're going to measure copper's capacity to store energy. So we have our water here, also starting with an initial temperature of 27.5 degrees. 27.5 for our 30 milliliters of distilled water. Put that in here. And we're going to find the final temperature, copper. Okay, and we know that copper is an excellent conductor of electricity and heat, which is why we use it for wires and for pots for cooking. Okay, let's see. And we're trying to keep it covered, get all the heat into that water there, and it's gone up significantly. We're at 37 degrees Celsius right now. $38. 38.1. What is that? That's about 38.5 when it's not at an angle. You guys know that you can't take readings from above or below, right? Because then it distorts your reading. So you have to be at eye level like I'm right now, and it's gone down to 38. So I believe the high was 38.5. Let's see if we got all the heat out of there. Yep. Okay. So now since the temperature is slowly rising as it loses heat to the surroundings, we know that we record the high temperature of 38.5. All right, so we're going to put all of our data into a chart. You can choose to use my chart or you can make your own.